Alright guys, this is your next question from Cat 23, the third slot. Please pause the video and try it out once and you can resume for the solution. Alright, so it's a tricky question guys. Many people fall for the trap, but you have to be very careful. We will see how to tackle this question now. So let n be any natural number such that 5 raised to n minus 1 is less than 3 raised to n plus 1. Then the least integer value of m that satisfies 3 raised to n plus 1 being less than 2 raised to n plus m for each such n. That is the catch guys. For each such n. So whatever is the least integer value of m you are finding, it should be satisfied for each value of n that you take. It should satisfy every value of n that you take. That's the catch. People just take the smaller values of n and satisfy. No, that's wrong. You have to find that value of m which satisfies all possible values of n in this case. So let's start. We first start by observing that n is a natural number. The inequality is 5 raised to n minus 1 should be less than 3 raised to n plus 1. Now let's start by taking n is equal to 1, a natural number. The left hand side will be 5 raised to 1 minus 1, 5 raised to 0. And the right hand side will be 3 raised to 1 plus 1, 2. The right hand side is definitely more than the left hand side. So n is equal to 1 is an acceptable value of n. Next, we take n is equal to 2. The left hand side is 5 raised to 2 minus 1, that is 1. And the right hand side is 3 raised to 2 plus 1, that is 3. 3 cube is definitely more than 5 raised to 1. So yes, n is equal to 2 is also an acceptable value of n. Next up, you take n is equal to 3. Left hand side is 5 square. Right hand side is 3 raised to 4. 3 raised to 4 is still more than 5 square. So yes, n is equal to 3 is also acceptable. Same way, you can take n is equal to 4. It will be 5 raised to 3 on the left hand side. And your right hand side will be 3 raised to 5. That's 243 is definitely more than 125. So yes, acceptable. Next, you take n is equal to 5. You have 5 raised to 4 and right hand side is 3 raised to 6. This is still greater guys. 3 raised to 6 is 729 and 5 raised to 4 is 625. Acceptable. But once you put n is equal to 6 guys, the game changes completely. Now the left hand side is 5 raised to 5 and the right hand side is 3 raised to 7. 5 raised to 5 is 3125 while 3 power 7 is 2187. So now the left hand side is greater. So n is equal to 6 is not acceptable and matter of factly then all subsequent values of n are also not acceptable. So in this question n can take exactly 5 values. They are 1, 2, 3, 4 and 5. Hi, don't forget to check out my course for the Quant section of the CAT exam where I've explained all concepts, tips and tricks, shortcuts and past year questions. Now the second expression is 3 raised to n plus 1 should be less than 2 raised to n plus m. Right? Now in this, I want the least value of m that satisfies this given relation. Now, I've already found the values of n as 1, 2, 3, 4, 5. The highest value of n is 5, right guys? So if I satisfy this condition for n is equal to 5, automatically all the other conditions will get satisfied. Let's put n is equal to 5. The left hand side becomes 3 raised to 5 plus 1, that is 6. Your right hand side would be 2 raised to 5 plus m. 3 power 6 is like 729. Okay. Now I want a power of 2 which is more than 729. Right. So 512 is less than 729. 1024 is just more than 729. Right. So I need this to be at least 1024 which is 2 to the power 10. So 5 plus m should be minimum equal to 10. And that's how m should be minimum equal to 5. Right? Now guys, if you take any subsequent value of n, for example, if you take n as 4, the left hand side is lesser. So m will be lesser than that. Right? So taking m is equal to 5 will satisfy all the conditions from n is equal to 1 to n is equal to 5. And that's how the answer to my question is the minimum value m can take is 5.